Hi, this is Charlie Calvert, and why don't we take a minute here talking about why we create methods. There's no question that as beginning level students, a lot of people struggle with the whole act of having to create methods, and so let's talk about for a minute why we do it. Well, one of the key things to grasp is that as you program for a while, some of the things that seem difficult at first become increasingly simpler. The first time you see a for loop, the first time you see a while loop, the first time you declare a variable, the first time you use some operators to return results, it seems complicated. But these are tools that we use day in and day out. So maybe you would see four for loops and 10 while loops during an average day of programming. And after 10 days of programming, you've seen a lot of while loops. You've seen a lot of for loops. After 30 days, you've seen a lot more. After a year or two, you get to the point where for loops and while loops lose their mystery to you. You understand them. But another problem keeps coming up, and that's the complexity of the programs we write. Let's take even simple programs that I could give as an assignment to my students only a few weeks into their programming career. And if you look at this, you'll start this program without really seeing what it is. You'll see that it consists of 5 or 6, maybe even 10 screens worth of data. There's 158 lines of code in here, and what's really 169 lines of code, and what's really quite a simple program. As you build up more complex programs, what you find is you end up not with 170 lines of code, not with 1,000 lines of code, not with 10,000 lines of code, but with hundreds of thousands of lines of code. And the problem isn't how do I do a for loop, how do I do a while loop, how do I declare a variable. The problem is how do I deal with the complexity involved in such a large program. The program that we were just looking at was declared all in one method. We hadn't yet covered the subject of methods, and there was no way to break our code up into smaller units. It turns out that that one key, that one idea, can I break up my code into a series of smaller units? Can I use divide and conquer as a strategy to deal with complexity? Turns out to be an enormously useful, profoundly powerful idea in the history of programming. It came about, people began to really see it in the late 60s, early 70s. A man named Dijkstra came up with some theories about how to divide our code up into methods, into what were called procedures and functions at the time in order to deal with this complexity. The basic unit that we're dealing with here, if we take things up another level, is abstractions. It turns out that we can deal with complexity by wrapping parts of our program into an abstraction. Okay? And abstraction is a very abstract word. It's not very precise, and that's precisely because it's designed to cover a broad spectrum of possible solutions. Anytime we can take a chunk of code and bundle it up into a discrete unit and tuck it aside and just say, now I'm going to give you this task and you go do it without us having to understand how that particular chunk of code performs the task, then we are successfully creating an abstraction. Let's see the simplest possible example of what this could mean. I'm going to declare a variable of type int, which is result, and I'm going to set it equal to 12 times 12. What I'm doing in this particular case is I'm squaring the value 12. And that's an operation that one might want to perform over and over again in multiple programs, is squaring a number. Okay? Now, we can help to generalize this. We've learned some tools already how to generalize certain ideas, and we can say, well, we're 12 times 12 is very specific. Can we generalize it a little bit? We could say we could create a variable called number to square, and we could set that equal to 12, and now we could multiply number to square times number to square, and in some ways we've helped to simplify our problem a little bit, because we're able to simply change one part in our code. Now we're squaring the number 6. Now we're squaring the number 7, right? But it turns out there's an even better way to work with this, and that's to create an abstraction, which is called a method with a name like square. And here we can use some of the tools built into Visual Studio. We can say that we want to create a new method called square. And now we do that, and we use the refactoring tools built into Visual Studio to create a method called square. Now, whenever we want to square a number, we can just call square. In other words, we abstracted away the details of you square a number by multiplying one number times another number. Okay, and we put it in a place called square, and now we never have to think about that detail again. How do I square a number? Well, I multiply one number times another. All we have to do is call square, and it will perform the task for us. This is what we mean by an abstraction. The method square becomes an abstraction around the idea of multiplying two numbers together in order to find their square. Okay, so that's useful and that's nice. It's very powerful, but you might say, well, I could have multiplied those two numbers together myself. It wasn't really that difficult. This is true, but it turns out that all of our programs tend to be made up of relatively simple tasks that could, in fact, be simple to do once. But when we need to do them multiple times, it's best to abstract them away. We get several benefits from doing this. One of the major benefits we get is reuse. We can reuse a method like square over and over in our program. So if we want to call square again later, we can do it easily. We can say number 2 square equals 12, and then we can just call square again and pass in number to square, and now we have effectively repeated the task. We've reused the code for the method square. We've used it once up here, and we've used it down here. Okay, so reuse is one of the big advantages of working with methods that we have over and over again. Another thing is it avoids repetition in our code. If we had to write number x times number x over and over again, then we keep repeating the same formula. Here's how you do something. Here's how you square a number. Now we only do that once. We do it in the method square, and we call it over and over again. If we discover that there was something wrong with our algorithm for squaring numbers, we only need to change it in one place inside the method square. So that's another huge advantage of writing methods. But the biggest one is it allows us to break long programs up into small, discrete chunks. All right. So if we want to get input, for instance, we can sometimes prompt the user for a number, and we say enter a number, and then we read that number in so we're able to perform that act there. Well, what if we want to do that multiple times in our program? Isn't it simpler to encapsulate it inside a method? Well, of course it is. So we can do that very thing. We can encapsulate it inside a method called getInput, or getIntegerInput perhaps. And now we go ahead and we do that, and then we want to make one change to the code that was automatically done. We might want to pass in a different prompt at different times. So we declare a variable called prompt, and then we set about completing our abstraction here. And now we have created a reusable chunk of code called getIntegerInput, which we could reuse multiple times in our program simply by cutting and pasting it into place. Okay, so now to finish up the program here, we would want to display the results twice. Now, I'm going to go ahead and leave things just like this once and run the program for you. So we enter a number 12, it works pretty well. We enter a number, another number, and it works. You know, clearly we've written code that's actually usable here. I like everything about this. I like the fact that get an integer input, we're avoiding repetition. Instead of repeating this code over and over again, we just call get an integer input twice. We've encapsulated the idea of squaring in numbers here inside this abstraction called square, and we call it twice so that we again avoid repetition. If we want to make a change, say call try parse instead of having to change it 2 places in our program, we only have to place it 1 part in our program. Now, when we look at this code, you'll notice one funny thing about it. Here's a line of code which is identical to this line of code. And you might say, well, these lines of code are so simple, Charlie, that why don't you just leave them as they are? And some people would. But I say whenever you see this, you should sort of smell trouble. You go, wait, here's code that's identical in 2 different places. So let me abstract it away. Avoid repetition in your programs whenever possible. So let's go ahead and do that. And now we've created a method called display result, and we call it twice instead of having identical code any place in our program. And then if we want to make a change to this, say suppose we wanted to display it as currency instead, we only need to make the change in 1 place in our program. Yet when we did this and we run the code again, we find that everything continues to work as expected. We didn't break anything by doing this. That's what we mean by refactoring our code. We make changes to our program in order to improve its readability and usability without actually adding any new features. And this concept is so important that there's a menu item up here called refactoring built into the IDE, which you can use whenever you want to. I just know the hotkeys, so I was doing them automatically. But here's how you can do that refactoring if you want to in your code. Remember, let's avoid repetition. Let's promote abstraction. And let's keep the methods that we create simple. You might look at these methods and say, gosh, Charlie, these are awfully simple methods. Well, those are good methods. Simple methods are good methods. We want to make sure that we break our code up, divide and conquer, break it up into small, discrete units that are so small that they're almost rock solid, inviolable. Nothing can go wrong in these little simple methods. And then we can build classes that have just a few simple methods in them. So our classes should be simple. And then if we want to break up those into assemblies or into libraries or into some other abstraction, we should keep those simple too. Looking for simplicity is very important. Your programs will get complex enough on their own due to their sheer size. Keep the code you write simple. And one thing I forgot to mention here was this concept of reuse. Say, by architecting your code properly, you can easily promote reuse. Here, if we want to, because we've abstracted away our prompt, we can change the prompt very easily without ever having to change get integer input. So we know that this code is simple, we know it's tested, we know it works, yet by passing in slightly different parameters each time, we can change the usability of our code, make it a little bit easier for us to use, for another person to use, because we've properly abstracted ideas. So I'm going to leave it at that. Recommend that you use abstractions, you promote reuse, you avoid repetition, and that you take the time to enjoy yourself. The programming is an endlessly fascinating game, and as you learn to write methods, you can really get into what's most interesting and exciting about it. So take your time to make sure you understand it and know how to pass parameters, know how to return results, and know how to enjoy yourself while you're writing code. Thanks for listening. Bye now.